Next kind of exponential equation finds an x on only one side in the exponent. So 11 raised to the 5x power equals 33. Let's solve this equation. The key to these is to get the x, or whatever expression is in the exponent, out of the exponent. So we're going to use some properties of logarithms and inverse functions to do that. So if you remember from before, if I want to undo this, I can figure out, well, what's that power? One thing I can do is I can take a logarithm of both sides. So if I'm going to take a logarithm of both sides, I'm going to choose a base that matches the base of the power, in this case 11. Because I remember from my properties of inverse functions that the log base 11 of 11 raised to the 5x power is equal to 5x. It's as if I'm canceling out the 11 part of the base. If I do something on one side, I better do the same on the other. Take the log base 11 of 33 on the other side. Now, this is an expression which I could evaluate using my calculator, and then understand that whatever this number happens to be, I'm going to take that divided by 5. I'll show that step quickly here before we go to the calculator. So that's what's going to happen. X is going to equal whatever decimal expression I get when I'm done typing that into my calculator. So here goes. We're going to take the log base 11, and I'll use my log base feature. The log base 11 of 33. I'll hit enter to evaluate it, and then if that's what I'm going to get, I'm going to take that divided by 5. I'll go ahead and take the previous answer, divided by 5, hit enter, and get 0.292. We'll round it to 3 decimal places in this case. So 0.292 would be the answer to my exponential equation. If you want to plug it back in and check it out, you certainly could. Now to do another one. As I try to get x out of the exponent, I see a power, but then I see some other stuff. Well, I need to get the power part of it by itself before I do the logarithm step. So here, my first step would be to add 5 to both sides. So now I have 2 raised to the 0.1x is equal to 12. To undo an exponential expression, I use a logarithm again. I'll take a logarithm with a base of 2. Because the log base 2 of 2 raised to the 0.1 times x is equal to just 0.1 times x. And then on the other side, I'll do the same thing. Take the log base 2 of 12. Now that's going to be an expression, once again, that will go into my calculator. And when I get that decimal number, I'll take it divided by 0.1 in order to get x by itself. So x is going to equal, I'll type that in, using log base. Take the log base 2 of 12 and enter, and then divide that answer by 0.1. I hit enter. I get 35.85. We'll round it to. So 35.85 is the answer that I write down. So that will be solving exponential equations where x is in one exponent only. Use logarithms to undo the exponential expression. Then solve for x, doing whatever it is that you need to do.